Welcome everybody. Today we complete part 2 of section 7.7 of AP Chemistry series. So pause the video and read the question carefully. The question is asking me about the concentration of the products in which we have, I2 and Br2. So I want to rewrite the equation down here. The equation says it's 2IBr. Okay, we have an equilibrium reaction. We have I2 and Br2. In all of these species, for sure, they're in a gaseous state. If we want to apply the rule of Rice at that point, it works, right? But let's see what are the given information. Now, according to the question, it says, what are the concentration of I2Br2 at equilibrium with 0.012 moles per liter of IBR? So at that point, we can notice that the only pieces of information that is given to us is the concentration of IBR at equilibrium, which is 0.0124. And since we have products at that point, then I have to say plus X, and here it's going to be plus X. And just keep in your mind, the value of Kc is given to us, right? Okay. So I need to calculate the value of X for I2 and Br2 in order to calculate their concentrations. So how can I do this process? All right, so let's move here. Since the value of Kc is given to me, then I have to say Kc is equal to the products. The products are I2 and Br2, right? And it's over the concentration of IBr to the power 2 because, it's multiplied by coefficient 2. And then I have to substitute the given information. The value of Kc is equal to 4.13 times 10 to the power negative 2, the value of I2 and Br2. So we have a value of X times another X over the given information, which is the concentration of IBr at equilibrium, which is 0.124 to the power 2. And if you just do some calculations and some math skills in here, just let's erase this stuff, it's going to be 4.13 times 10 to the power negative 2 equals to X squared over the concentration here, 0.0124 squared. The value of X squared, if you just make cross multiplying, the answer is equal to 0.0000635. And since I need the value of X, I have to take the square root. So X is equal to 2.52 times 10 to the power negative 3. Now the question NB says, what is the initial concentration of IBr before equilibrium was established? 2IBr. This is here to give you I2 and Br2. All right, so what is the only type, or what are the pieces of information? We just noticed that at initial time, we had initial concentration. It was trying to lose its concentration. I have to say initial concentration minus 2x. After losing the 2x, it becomes 0.0124, right? Which is the one at equilibrium. I have to take it. Okay. Now I just say, okay, the initial is unknown, minus I determine the value of X. Actually, it represents it's in here, calculate it. So you have to say it equals to 2 times 2.52 times 10 to the power negative 3, okay? And the overall answer is equal to 0.0124. Now I have to do some math. I minus 0.005, okay, equals 0.0124. And then I have to say plus 0.0050 plus 0.0050, and then you will end up with an answer of 0.0174. So the initial concentration of IBr was 0.0174, and then it started to decrease until it reaches to the concentration of equilibrium, which is 0.0124. And now let's solve the last question. Pause the video and read the question carefully. First of all, you have to look at your equation here. You have 3 moles of A, that this is here to give you 5 moles of B and 2 moles of C, and all of these guys are in aqueous form. The first piece of information that is given to me is we have 0.924 moles of A. Then you have to say this is reaction. The initial concentration of A is 0.924 and the volume is 1 liter. So it's a good point to make our calculations easier, in which we divide over the volume of 1. Okay, and since we're talking about initial, then we have 0 for all of these guys in here. And the change, since the question is telling me that we have a dissociation of A, I have to subtract for the change 3x in here plus 5x in here plus 2x. Okay, the question is asking me to calculate the value of Kc of this reaction. So if I determine the concentrations at equilibrium, then I can determine the value of Kc easily. So how can I determine the value of x? All right, the question says, how can I determine the value of x based on this percentage? We started with 0.924 of A, right? So it was initial. But 38.8% of A was lost, or in other words, it's dissociated. So how can I determine, like in terms of amount, what was the amount of concentration that is lost instead of percentage? Then I have to say, okay, if you have the value of A, which is 0.924, and if you multiply by the percentage of 38.8%, then it's going to be 0.3585. So at that point, I can say, yes, this amount was lost from A. Okay, so if you go to the concept, or let's say to the expression in here, you can notice that the 3x here represent loss. What I have to say, okay, the 3x is equal to 0.3585. If you divide it by 3, then the value of x is equal to 0.1195. So I can say, yes, everybody's happy. I determined the value of x. Then I have to substitute the values of x in here. I have to say 2 times 0.1195. And here we have to say 5 times 0.1195. And here we have to say 0.924 minus 0.3585. Okay, to determine the A at equilibrium, you have to say 0.924 minus the whole thing that was like lost from A, and that's why it's going to be 0.3585. And then you have to say the answer is equal to 0.5654, which is the concentration of A at equilibrium. So yeah, what's going to be the answer of A at equilibrium? Let's write it in, let's say, let's use another color. Okay, let's take it green. The concentration of A becomes 0.5654. If you multiply 5 times this value, it's going to be 0.5975. And 2 times 0.1195 is equal to 0.239. Now, the last step is writing the value of Kc and substitute the answers. So it's going to be, you know, the Kc expression is equal to products of reactants. All of these products and reactants are in gaseous, so they're accepted in Kc. So I have to say it's B to the power 5 times C to the power 2 over the value of A to the power 3. If you substitute them, they're going to be, the concentration of B is equal to 0.5975 to the power 5, and the value of C is equal to 0.239 to the power 2 over the concentration of A, which is 0.5654 to the power 3, 0.0241.